Alright, here we are for Unit 2A, Lesson 2.1. So we're dealing with the polynomial identities, and as you should have, I gave you some notes with these identities here. Okay. Now, if we look at the first three, these are identities that, and identities are basically just rules. They're just kind of like shortcuts, essentially. So what we're looking at here is if we're given some multiplication in these formats, so either two binomials or a binomial squared with plus or minus, or a trinomial squared, we can use this pattern. Now with these ones we can also just use that area model, right? So on the questions that deal with that, I'll do it both ways for you. So that would be like 1 and 2 and 7, okay? And then we'll look at those, okay? So, looking at the first one, we've got the square and we've got the minus, okay? So if we look at this, oops, too far. Okay, this would be the formula, so it would be a squared minus 2 times a times b plus b squared. So x would be like a, 16 would be like b. So I'd go a squared, so x squared minus 2 times a times b plus b squared. Okay, then I could simplify it from that. X squared, 2 times negative 16 would be negative 32x, plus 16 squared I believe is 256. Let me grab a calculator. Yep, 256. And that's all we had to do. Okay, that's using that pattern. Okay. Now, we could have also just done the area model and went x and negative 16. Because it's squared, it's twice. X and negative 16. Got x squared, negative 16x, negative 16x, and positive 256. And then realize those together would get us x squared minus 32x, negative 16 plus negative 16 is negative 32, plus 256. So either one works. Now, we look at number 2, we've got a square here, and we've got plus. So 4x would be like a, 21 would be like b. So for this one, we just do a squared plus 2ab plus b squared. So I'd go 4x squared plus 2 times 4x times 21 plus 21 squared. Okay. Now using a calculator, we find that 21 squared is 441. Okay. 2 times 4 is 8. 8 times 21 is 168x. And then 4 squared, remember when you're squaring something like that, you square both pieces, so that'd be 16x squared. Okay. Could I use the box method, the area model? Yeah. 4x positive 21, 4x positive 21. So that'd be 16x squared. 4 times 21 would be 84x. 4x times 21, 84x, which add those together, 168. There's your 16x squared. 21 times 21, 441. There's your plus 441. Alright, this last one has 3. Okay, so it would be this one. You take every term and square it, then 2 times every term multiplied by the other. So AB, BC, AC. Okay, so that would be A, B, and C. So for this one, it would be x squared squared plus x squared plus 3 squared plus 2 times AB, x squared times x, plus 2 times BC times x times 3, plus 2 times AC, x squared times 3. Then we simplify. That would be to the fourth, x to the fourth, plus x squared, plus 9, plus 2x to the third, plus 6x plus 6x squared. Then combine any like terms we have, which it looks like we just have the square terms. So it would be x to the 4th plus 2x cubed plus 7x squared plus 6x plus 9. And that's where we would end up. Okay, could we use the box method here? Yeah, we would just make it 3 by 3, right? X squared, x, and 3. X squared, x, and 3. So x squared times x squared, x to the 4th. X squared times x, x to the 3rd. X squared times 3, 3x squared. X squared times x, x to the 3rd. X times x, x squared. 3 times x, 3x. X squared times 3, 3x squared. X times 3, 3x. And 3 times 3 is 9. Then we combine. That one stays by itself. Those two combine. 2x cubed. These 3 combine, so 3 plus 1 plus 3. 7x squared. 3x and 3x give us 6x and then 9. Okay, so whichever way you deem easier, that's what you do with those ones. Okay? Now, 8, 9, and 10, they're wanting you to see what you can do to simplify it. Because in other words, they're saying, okay, the side length of a square is 530. We know 530 squared is going to give us the area. But they want you to try to do that without using your fancy, without using a calculator. In other words, you'd have to split it up into stuff like this. Okay, but before we do that, let's take a look at these other ones we didn't look at. So 3, 4, 5, and 6. These ones deal with this part, okay, which you can't use the area model on this one. Okay, so these ones you need to look for this, either a cubed plus b cubed, a cubed minus b cubed, or a squared minus b squared. And then you can turn them into this pattern. Okay, it's the difference of two squares, sum of two cubes, and difference of two cubes. So, looking at this first one, okay, the first thing we need to notice is it's got a square. That should key us. We should also know something about the number 104. Okay, 100 is really 10 squared, right? So 100x squared is really 10x squared. Minus 4, which is really 2 squared. See, now a is 10x, b is 2. Now we can use this one, the difference of two squares. So it's a plus b times a minus b. So 10x plus 2 times 10x minus 2. The hardest part on these ones is figuring this concept out. That's the toughest part. So if we look at 4, it's also got a square. So do I know what 81 is? Well, that would be x squared minus 81 is really 9 squared. 9 squared. So using that same pattern, I go x minus 9, x plus 9. Doesn't matter which order I put them in. And that's how I get those ones. Now the next two we should notice are cubes. Okay, knowing your cubes numbers is usually a lot more difficult. Okay, so here's a few to let you know about. And it'd be a good idea, if you don't have these written down already, to write them down. Okay. These may pop up, and there's something you're going to want to know. And we'll actually use almost all of them. So once again, I've got the cubes, and a plus, cubes, and a minus. So I know that I'm going to use these plus and then minus. So 27 is 3 cubed. So 27x cubed would be 3x cubed. 343 is 7 cubed. So I'd have 3x cubed minus 7 cubed. So that's A, that's B. So the pattern here is A plus B, then A squared minus AB plus B squared. So I'd go A plus B that should have been plus, huh? Times a squared, 3x squared, minus a times b, right? Yep. 3x times 7 plus 7 squared. So simplifying that, 3x plus 7 times 9x squared minus 21x plus 49. And that's my answer. That's what they're looking for us to do, to expand or factor. This would actually be factoring, not expanding. Okay, number 6. Same idea. We've got 8, which would be 2 cubed. And then 512, which would be 8, so it would be 8x cubed. So 8x is a, and 2 is b, so then we use this version where it's a minus b and then it's plus in here. So it would be 8x minus 2 times 8x squared plus 2 times 8x plus 2 squared. So 8x minus 2 times 8 squared is 64x squared plus 2 times 8 is 16x plus 2 squared is 4. And there's our answers for those ones. Okay, now looking at these ones, we want to try to split things up into numbers we may or may not know that might be easier to deal with. Okay, that we can do without using a calculator. So, I look at 530. Okay, so it's 530 squared. Well, couldn't I split that up into 500 plus 30 squared? Then wouldn't it look like this one right here? So I could simplify it using that. Yeah, that's essentially what we want you to do. So it would be 500 squared plus 2 times 500 times 30 plus 30 squared. Well, 500 squared, what's that going to be? Well, that's 500 times 500, right? Which we know 5 times 5 is 25. So then just we have to think about the zeros. So 0, 0, 0, 0. So we do the 4 zeros, okay? That's kind of easy to see. Even though, so 250,000. Plus 2 times 500 is 1,000. Times 30 is 3,000. Okay? Plus 30 squared, 30 times 30. 3 times 3 is 9. 2 zeros, 900. Now these we should be able to add together better, right? Would be 253,900 feet squared. So that's kind of the idea, is that you can use easier methods, and it's just practicing what we needed. Okay? I think I made a mistake though, didn't I? That's I apparently forgot to put something in, because I was just double checking on my calculator. Apparently I've missed out on something, because if you go 530 squared, you should end up with 280,900. So, oh duh, that should have been 1,000. So 1,000 times 30. So that should have been 30,000, which would make it, there we go. Okay, so we had the right process, it's just made a stupid mistake. So that would add up, right, like this. So we'd end up with 280,900. There we go, much better. Okay, so then we just do the same thing with number 9. Okay, and using these numbers that are easier to split it up into. Now, you could split it up into a variety of numbers. I just think 400 plus 70 is pretty easy when I don't make stupid mistakes. So that's the same thing that we were doing. Okay, we could also do slightly different, and we could have went 500 minus 30, couldn't we? And that would change which one we use, which would only change one thing. So if we still had that other stuff up there, it'd be 500 squared minus 2 times 500 times 30 plus 30 squared. Well, we knew that one was 900. This one, 250,000. We knew this one was 3,000, right? 2 times 500, 1,000 times 30, 3,000. So we'd end up just subtracting 30,000, I mean, not 3,000. Okay, and getting 220,000, then adding 900. So we get 220,900 feet squared, or meters squared. Okay, so that's kind of that way. We could have also went 400 plus 70 and done it that way as well. Okay, now the last one, 310. Okay, and we could even split these up into, 3 numbers if we really wanted to, or a variety of different things to help us figure out what was going on. Okay, so there's a lot of different things we could do in order to get this to work. So for 310 squared, probably the easiest is 300 plus 10 squared. I think those are the easiest, so then I'd go 300 squared plus 2 times 10 times 300 plus 10 squared. 10 squared is 100. 300 squared is going to be 9,000. 90,000. Right? Yeah. Then 2 times 10 is 20, or we could go 10 times 300, that would be 3,000, times 2, that would be 6,000. Add those together, or would it be 60,000? No, 6,000. Trying to preempt a mistake there, so then it would just be 96,100 centimeters squared. And there we go, guys.